Alright, so this is the final rule when it comes to differentiation. So we've learned the chain rule, we've learned the product rule, and the final one is called the quotient rule. And so the quotient rule is used when we have to differentiate a function where we have a fraction, so one function above the other. The product rule was used when we have two functions multiplied together, right? And the chain rule was when we had a composite function. This is when we have a fraction, okay? So I've written out the quotient rule, which is given in the formula booklet, so you don't have to technically memorize this, but it's good to get very familiar with it. First things first, unlike the product rule where the order doesn't matter, so you can set anything to U, set anything to V, for the quotient rule, the order matters a lot, so you have to be very specific. So they've written it in terms of F prime and G prime and F, but I'm going to write it in terms of U and V. So if we have a function where Y is equal to U over V, so we have one function above the other, then when we differentiate it, it becomes V times U prime minus U times V prime over V squared. So this is very, very important. You can't flip them around, you can't put plus, you can't change the order around, because it has to be in this specific order. Another thing to note is, the product rule, we could set anything as U and anything as V, right? In this one, the numerator always has to be IU, and the denominator always has to be RV. If you flip them around, then you get the incorrect answer. But apart from that, if we follow this rule, then we can pretty much differentiate any function. So let's say we want to differentiate y is equal to, let's start off with something simple. So x squared over e to the 2x. So we have one function above the other, it's a fraction. So therefore, if I were to differentiate it, I need to use the quotient rule. And so I have to set my u and v. Remember, for the quotient rule, the u and v is very important. So our u has to be the numerator, which is x squared, and our v has to be the denominator, which is e to the 2x. But now I differentiate them separately, so this is simply 2x, and v prime is equal to 2e to the 2x. And if I want to now find the final answer, derivative, then I have to follow this rule very specifically. So it's going to be v times u prime, so v times u prime, these two, so it's going to be 2x e to the 2x minus, make sure it's a minus always, u times v prime, which is going to be these two values here. So that's going to be 2x squared e to the 2x, like this. And that's all over v squared, okay? And our v was e to the 2x, so it's going to be e to the 2x squared, like this, okay? And so this will be the derivative of our initial y. Obviously, you can cancel it out and make it more simple, which they do want you to do in exams. Right, let's try another example here. So let's try, say I want to differentiate y is equal to sine x over ln x squared, like this, okay? So it's a fraction, so we know we should be using the quotient rule. Our u is the numerator, in this case sine x. Our v is the denominator, so ln x squared. We differentiate each one separately, so differentiating sine x, we get cos x. Differentiating ln x squared was going to be x squared on the bottom. We differentiate x squared, gives us 2x, so I can cancel that out to be 2 over x, like this. Now, dy by dx is v times u prime first, so these two first, so it's going to be cos x ln x squared minus u times v prime. So it's going to be 2 over 2 sine x over x. And that's all over v squared. So v being this, so ln x squared all squared. Okay? So it's not ln x to the power 4, it's ln x squared all squared. And you can manipulate it and simplify a bit further, but I'm just going to leave it like this. Let's just try one final example. So let's say I want to differentiate y is equal to the root of 2x plus 1 over x squared. Okay, so don't get confused, don't get rattled by this. Once again, just simply state your u and v first. So u is the root of 2x plus 1, so I'm going to rewrite that as 2x plus 1 to the power of a half. V would therefore be x squared. So u prime, because we've raised something to the power, we know that we should be using the chain rule. So half, this would be half times 2 times 2x plus 1 to the power of minus a half. V prime would be 2x. Now once we've got this, then our dy by dx is going to be v times u prime first, so these two first. So this will cancel out, so I'll get x squared times by 2x plus 1 to the power of negative half minus these two multiplied together, so 2x times 2x plus 1 to the power of positive a half all over v squared, v being x squared, so x to the power of 4. So it doesn't really matter how difficult the functions, individual functions get. You can use the quotient rule to differentiate any function which has a fraction. So these are the 3 rules that we've learned now. So in the next lesson, we're going to be looking at trig rules and trig terms and how to differentiate trig terms and apply these rules to trig terms.